that yet, you do want to respond to the poll. Getting closer. I have 21 students connected. 22 students. So we need 25. There's 3 more people that still need to join. Okay, so this is the lesson that we're going to be doing today. And this week so far, we've been reviewing how to graph a single linear inequality. And so today we're going to look at graphing systems of linear inequalities. All right, so instead of graphing just one inequality, we're going to be graphing 2 inequalities at the same time on the same coordinate plane. And this is 12.2 from your textbook. Your EQ is how do you solve a system of linear inequalities? Your learning goal is I can graph the solution set to a system of linear inequalities in 2 variables as the intersection of the corresponding half planes. Okay, so what does that even mean? I'm going to show you real quick. So this is kind of not specifically in the lesson, but I do want to show you in Desmos and just make this connection for you guys. So we have our graphing calculator. Say I typed in just an equation. Equation and inequalities are different. If I typed in y equals 3x plus 3, I don't know where that JK came from, plus 5. Okay, so that right there, this is an equation. This is a linear equation. It has an equal sign. If I change that equal sign to an inequality symbol, then the line stays there, but it may change to dash depending on which symbol you use, and you will have shading on one side or the other. This is a half plane shading. So half the coordinate plane is shaded right now. So the coordinate plane is infinite. As I zoom out, I can't zoom out enough to see everywhere it shades because it goes on forever. Now as I change this symbol, if I do greater than, I'm going to flip it around. I can use the keyboard here to change it to these symbols. Okay, and that's a solid line instead. So what we're going to be doing today is looking at 2 linear inequalities. And we're going to be looking for where they intersect. So when you graph 2, you get 2 half planes, and you know there is going to be some area that they're going to overlap. All right, so that's what today's lesson is about. And I'm going to show you a video from Khan Academy to get us started on that.
Graph the solution set for this system. And it's a system of inequalities. We have y is greater than x minus 8, and y is less than 5 minus x. So let's graph the solution set for each of these inequalities. And then essentially where they overlap is the solution set for the system, the set of numbers that's, or the set of coordinates that satisfy both. So let me draw a coordinate axis here. So that is my x-axis. And then I have my y-axis. And that is my y-axis. And now let me draw the boundary line, the boundary for this first inequality. So the boundary line is going to look like y is equal to x minus 8. But it's not going to include it because it's only greater than x minus 8. But let's just graph x minus 8. So the y-intercept here is negative 8. When x is 0, y is going to be negative 8. So we just go negative 1, negative 2, 3, 4, 5, 6, 7, 8. So that is negative 8. So the point 0, negative 8 is on the line. And then it has a slope of 1. This is you don't see it right there, but I could write it as 1x. So the slope here is going to be 1. I could just draw a line that goes straight up, or you could even say that it'll intersect if y is equal to 0. If y were equal to 0, x would be equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so this is x is equal to 8. But it has a slope of 1. For every time you move to the right 1, you're going to move up 1. So the line is going to look something like this. And actually, let me not draw it as a solid line. If I did it as a solid line, that would actually be this equation right here. But we're not going to include that line. We care about the y values that are greater than that line. So what we want to do is do a dotted line to show that that's just the boundary, that we're not including that. We're not including that in our solution set. Let me do this in a new color. So this will be the color for that line, or for that inequality, I should say. So that is the boundary line. And this says y is greater than x minus 8. So you pick an x, and then x minus 8 would get us on the boundary line, and then y is greater than that. So it's all the y values above the line for any given x. So it'll be this region above the line right over here. And if that confuses you, I mean, in general, I like to just think, oh, greater than is going to be above the line. If it's less than, it's going to be below a line. But if you want to make sure, you can just test on either side of this line. So you could try the point 0, 0, which should be in our solution set. And if you say 0 is greater than 0 minus 8, or 0 is greater than negative 8, that works. So this definitely should be part of the solution set. And then you could try something out here like 10 comma 0 and see that it doesn't work. Because you would have 10 minus 8, which would be 2, and then you'd have 0, and 0 is not greater than 2. So when you test something out here, you also see that it won't work. But in general, I like to just say, hey, look, this is the boundary line, and we're greater than the boundary line for any given x. Now let's do this one over here. Let's do this one. The boundary line for it is going to be y is equal to 5 minus x. So the boundary line is y is equal to 5 minus x. So once again, if x is equal to 0, y is 5. So 1, 2, 3, 4, 5. And then it has a slope of negative 1. We could write this as y is equal to negative 1x plus 5. That's a little bit more traditional. So once again, y-intercept at 5. It has a slope of negative 1. Or another way to think about it, when y is 0, x will be equal to 5. So 1, 2, 3, 4, 5. So every time we move to the right one, we go down 1 because we have a negative 1 slope. So it will look like this. And once again, I want to do a dotted line. I want to do a dotted line because so that is our dotted line. And I'm doing a dotted line because it says y is less than 5 minus x. If it was y is equal to 5 minus x, I would have included the line. If it was y is less than or equal to 5 minus x, I also would have made this line solid. But it's only less than. So for any x value, this is what 5 minus x. 5 minus x will sit on that boundary line. But we care about the y values that are less than that. So we want everything that is below the line. And once again, you can test on either side of the line. 0, 0 should work for this second inequality right here. 0 is indeed less than 5 minus 0. 0 is less than 5. And then you could try something like 0, 10 and see that it doesn't work. Because if you had 10 is less than 5 minus 0, that doesn't work. So it is everything below the line like that. And like we said, the solution set for this system are all of the x's and y's, all of the coordinates that satisfy both of them. So all the shaded in purple satisfies the second inequality. All the shaded in green satisfies the first inequality. So the stuff that satisfies both of them is their overlap. So it's all of this region in blue. Hopefully this isn't making it too messy. All of this region in blue where the two overlap, below the magenta dotted line on the left-hand side, and above the green magenta line. That's only where they overlap. So it's only this region over here, and you're not including the boundary lines.
All right, so you guys should be in the Google Meet tab right now. You should be looking at our Google Meet screen. So you do have to kind of go back and forth between Pear Deck and our Google Meet. The times that you want to be in Pear Deck are when you're doing the interactive slides. Okay, you want to have it open, but right now if I'm talking to you, you probably want to be more in the Google Meet because I might be trying to show you something. So that video was just an example, really like thorough example of how you graph a system of inequalities. And it's really similar to graphing a system of equations, okay? The only difference is they're not equations, they're inequalities. And the other difference is that when you have a solution to a system of inequalities, it's not just one point. It's a whole bunch of points. It's an infinite amount of points, okay? And this is kind of like a way to break down the steps to solving a system of linear inequalities using the graphing method. And so the first step would be to graph and shade the solution to your first inequality. And so that's our one that we have in green here. And you can see it, it's over here. The y-intercept is +2. So we're at +2. on the y-axis, and then the slope is the coefficient of your x term, -2. So my slope is -2. I rise 2 units and run 1 to the left, and then I connect the line. And this line is, in fact, solid because of the symbol that I have, and I shade above it because of the symbol I have. Step 2, you're going to graph and shade the solution to your pink inequality, the other inequality. So that's one is here. The y-intercept is -1. So that's where you have it crossing the y-axis. Your slope is 0 and 5/10, which is the same as 1/2. So a rise of 1 and a run of 2. 1/2 up 1 over 2. And then this is connected with a dashed line because of this symbol here. So when it's less than or greater than, it's a dashed line. When it's greater than or equal to or less than or equal to, then it's a solid line. Okay. This symbol for the pink inequality also means I shade below it. So if I'm looking for the solution to this system, step 3 tells me it is the overlapped shaded region. That is the solution to the system. It's this entire area that is dark green. Okay, and it's not just this area. It extends on forever out to the right and down. Any point that falls in this area is a solution to the system. So like the 0.50 falls right here, and it's in the system. The 0.05 is up here. This falls as a solution to the green inequality, but not a solution to the pink one. So that wouldn't be a solution. If I look at the 0.1, -2, right here, this would be a solution to just this inequality, but not to this one. So any point that I pick has to be in this dark green area. I can have points that are on this line here, but I cannot have points that are on this dashed line here. Okay, a solution where it has to be overlapping can't be on the dashed part. It could be on the solid line part because it is overlapping there. So with that knowledge, this is your first interactive slide now. So now you want to go to your Pear Deck tab. And I have a picture shown for you here. This is a graphed system of linear inequalities. The first inequality is y is greater than -3x plus 5. The second inequality is y is less than or equal to x minus 2. Okay, the blue dashed line is the blue inequality. The red solid line is the red inequality. And the shading is shown for each inequality. And there is an area where the two shadings overlap. Okay, what you're going to do is drag the star to any location that would be part of the solution. Your entire star needs to go somewhere where I would find a solution to the system. I have 7 of 26 responses. So you do need to participate. Everyone needs to do this. If you don't participate, that reflects your Aries codes. You don't want to get a non-responsive in Aries for not participating in the lessons. Don't be afraid of making a mistake. Just try it. Your name doesn't come up on this when I share it with the class. It's totally anonymous. You don't have to be worried about making a mistake. So you've got to go to your Pear Deck tab and drag your star somewhere where I would find a solution to this graph system of linear inequalities. I have 17 out of 26 responses. So let's see what we came up with. So we kind of have stars all over. We got stars in the purple, stars in the blue, stars in the white, stars in the pink, stars at the point where the two lines intersect. There's stars everywhere. And so real quick, I'm going to go back and show you the only place that is the solution is the area where the two shadings overlap. Okay, the green overlaps the pink. Okay, both of them are showing up. So this area is the only place there are solutions. There are no solutions in just green, just white, just pink. So you have to have your star entirely in the purple area, because the purple is where the red and the blue overlap. Remember, blue and red make purple? So your star should be there. And I do notice quite a few students, I've noticed this with my other math classes too, wanting to put the star where the two lines, the blue and the red line, intersect, because that is exactly what I taught you guys about solving a system of linear equations. Okay, in this case though, because this is a dashed line and this is a solid line, I wouldn't be able to put a point right there where they intersect, because I can't include anything on this dashed line. That's why it's dashed, because I can include anything right up to it, but not on it. So it has to be totally in the purple. You can have a point that falls on this red solid line, but not on the blue dashed line, but anywhere in the purple. Okay, now your next slide here, you are going to be in Pear Deck. In Pear Deck. And you're going to have the split screen shown for you. One half of your screen is this slide. The other half of your screen is the Desmos graphing calculator. And we are going to use the Desmos graphing calculator to graph the system of linear inequalities. So I would like everybody to go over to your Pear Deck tab. You want to click on your Pear Deck tab, and you are going to type in both inequalities. And as you type each one, it's going to pop up a half shaded plane each time you graph an inequality. And you're going to see there's going to be an area that overlaps. That overlapped shaded region, that represents all the solutions to the system. Any point, and for this problem, it's using red and blue as the two shading colors. That may change depending on, you know, the more you use Desmos, it'll rotate the colors around. But for this one specifically, it's going to show red for the first inequality and blue for the second inequality. And just like you know about primary colors, when you mix red and blue, you get purple. So the purple shaded area is the overlap shaded region. Any point in that purple area, that is the solution to your system. So you should be trying this in Pear Deck. I see maybe like half of you have tried it so far, which is great. So I'll give you about 30 more seconds to kind of play around with this, and then we'll move on to the next slide. Okay, so I'm going to move forward to the next slide, and we're going to work this one out together. So what I would like for you to do is come back to our Google Meet tab so you can see what I'm presenting. Go ahead and come back to the Google Meet tab so you can see what I'm presenting. And you can determine, it says, you can determine if a point is a solution to a system of linear inequalities by checking if it lies within the shaded area of the graph system. So we can use the Desmos graphing calculator to do this. And we are going to be graphing that system of linear inequalities and looking for the correct point that falls in the shaded area. So come back to Google Meet tab, because right now I'm presenting to you a giant graphing calculator. And what I'm going to do is type in each of these inequalities. So I'm going to start with y is greater than, and I do need to use the keyboard to get that symbol, negative x minus 4. Okay, so once I've done that, it's using a different color. It's using purple for this first inequality. The inequality graph is shown for me here in Desmos. So it's the half plane where everything is purple. It's a solid line because of the symbol. I need to now type the other inequality, which is y is less than 2x minus 2. All right, and it used kind of a gray color for me this time. And you can always drag your image around. You can change the zoom if you want to go by increments of 1. You can zoom in 1 time. And so I can see there's 4 distinct areas. There is the white area where neither inequality is. There's the gray area where just the second inequality is, the purple area where the first inequality is, and then there's the overlapped region where both inequalities are. So any point in this dark purple area would be a solution to the system. Any point not in the dark purple area, anywhere else, is not a solution to the system. Now, I have 4 choices. Okay, I have these 4 ordered pairs. And so my first ordered pair, -1, 4. Maybe I'm not real strong at graphing and I forget how to do that. One thing nice about Desmos is you can type in your ordered pair. So I'm just typing it in. And what it'll do for me, I have to zoom out, it's going to plot the point for me. Okay, so I'm going to do that with all these points. -4, -7. Okay, and -10 and 3. And one more point, I need 9, 9. All right, and so I can zoom out, and I'm now looking at all 4 points plotted. Okay, and they're color-coded. The red point is here, the blue point is labeled and it is here, the green point is here, and the purple point is here. So from this picture, now you should be able to drag your star to the point that shows, to the point that is a solution to the system. It's not the only solution, but it is a solution. So that's what I want you to do right now. Go to your Pear Deck tab. After looking at this picture that is on our Google Meet presentation screen, and identify which ordered pair represents a solution to the system of linear inequalities. Which of those points would be it? I have 10 responses out of 26. So make sure you toggle over to your Pear Deck and move your star to where you think the answer is. Okay, I'm up to 13 out of 26. I have half of you that are participating. I need full participation from you guys. You have to do this stuff. This is how you're going to learn how to do this. You have to participate. It's okay if you make mistakes and get it wrong. Don't worry about making a mistake. It's not a big deal. We're up to 18. Pick one. Which one is it? Which of those 4 order pairs is in the correct area to represent a solution to the system? Okay, most of you put the right answer, which is 9, 9. 9, 9. Okay, the point 9, 9 on Desmos is the only point that shows up in the overlap shaded area. The red point, negative 1, 4, is only a solution of the first inequality and not a solution of the second inequality. The green point, negative 10, 3, and the blue point, negative 4, negative 7, is not a solution of either inequality. The only point that works is 9, 9. So everyone's star should be on 9, 9. All right. So one more slide. I want you to think about this for a second. I'm going to give you a couple minutes to do this one. Do you think it's possible for there to be no solutions to a system of linear inequalities? So what we've looked at so far is that a solution to a system is when they overlap. So can you think of some way to possibly graph two inequalities so that they don't overlap? Is that possible? If you think it's possible, draw it. What would it look like? If you don't think it's possible, explain why not. I'm going to give you 2 minutes to do this one. So go to your Pear Deck tab and put something on the slide. That's what you got to do to participate. You got to go into your Pear Deck tab and participate. If all you can think of is yes or no, then just put that. If you're not sure, you can even put that too. Or say you don't understand. The whole point of these slides is to get feedback from you guys. Okay? You can be honest with me and tell me you don't get what's happening. Or if you think you get it, try to draw a picture. Is it possible for there to be no solution? No solutions at all. Is it possible to graph two linear inequalities where they wouldn't overlap sometime, at some point? So I'm looking, I have most of you working in Pear Deck. Jarelli, you need to go to your Pear Deck slide. Pedro, go to your Pear Deck slide, please. Emily, go to your Pear Deck slide. Brandon, go to your Pear Deck slide. Another minute, and we'll look at what you came up with in a minute. Okay, so it is 1:40. Let's take a look at what some of your peers came up with. Okay, so you can come back to the Google Meet tab, and I'm going to show anonymously responses. Says, I think it is possible it would be two equations that don't overlap. Okay, what would that look like? No, because then there would never be an answer. Okay, that's true. If they don't overlap, there is no answer. I think it's possible it would probably look like both of the equations not having an area that is shaded by both equations. Okay, yeah, that would be true. There would be an area where you're not having either one shaded. I know a lot of you are writing equations. It's easy to do, but remember, it's inequalities. We're talking about inequalities. There are equations when you have the equal sign, but when you have an inequality symbol, we call it an inequality. Yes, I think it is possible. You can graph parallel lines. Ooh, I like that. This is what it would look like. Okay, so here's two graph parallel lines. Okay, now when we worked on solving systems of equations, This is exactly what happened when we didn't have a solution. You guys remember that? If you graph two equations from a system of linear equations and they don't intersect because they're parallel, there's no solution. So it's very similar with linear inequalities. Okay. Okay. No, I'm confused. That's fine. Yes, sort of. There wouldn't be an answer. No. Yes, they would be lying. They could be parallel lines. Not sure. Looks like we're trying to graph something and shade it. So I'm going to go ahead and show you that it is possible. Okay, and a lot of you are on the right track. If you have parallel lines, maybe they don't overlap. And so this is an example where there is no solution. We have this red inequality line, y is greater than 2.5x plus 4, and we're shading this direction above the line. And then we have this line, y is less than 2.5x, and we're shading below the line. Because they have the same slope, the lines are parallel. So they never intersect. They go on forever and they never meet. And we're always shading away from each other. Now, it is possible that you might have parallel lines that do intersect, because they might say, if I was to reverse just the inequality symbol right here on the blue equation, if I change this to y is greater than 2 5/10 x, then I would be shading above the line, and actually there would be a solution. It'd be everything over here. There wouldn't be anything shaded on this side. So it is possible when the lines are parallel, but it also depends on the symbols a little bit. Okay.